So once again, welcome to today's webinar hosted by Teksun on an increasingly vital topic in our tech-driven world, that is DevOps with microservices. My name is Shivika and I will be your host for this session. We are delighted to have you join us as we explore how microservices are transforming DevOps practices. Our guest speaker, Technical Project Manager, Mr. Prabhat Gautam at Teksun is here to share his experience and insights on this topic. Whether you want to deepen your understanding or stay updated on the latest trends, you are in for an informative and engaging experience. So, the agenda is overview of microservices. Here Sir will discuss differences between monolithic and microservices architecture. Then he will talk about building microservices, wherein he will talk about choosing technology stack, communication protocols like REST and gRPC. Then we'll discuss about the deployment strategies, then the case studies, and finally, last but not the least, the question answer session will follow. So let's get started. Prabhat, the stage is all yours.
Thank you, Sevika. Good morning, everyone. Thank you for joining this webinar. And so let's start our webinar. Myself, Prabhat Gautam. I have 11 years of experience as a technical project manager. My expertise spans a variety of front-end, back-end, and cloud technologies like jQuery, Angular, React, Node.js, Python, Laravel, Java, MySQL, MongoDB, DynamoDB, PostgreSQL, AWS, Azure, and Google Cloud Services. I have a strong foundation in OOPS concepts and extensive knowledge of core PHP, HTML, CSS, Bootstrap, JavaScript, XML, and JSON. In addition, I also have experience with WordPress, Magento, Moodle, Blade templates, web services. I am proficient in third-party API integrations like payment gateways, SMS gateways, and social media APIs such as Facebook and Twitter. So let's begin with a quick intro. Teksun is a global engineering company which is certified ISO 9001:2015 that helps business solve complex software challenges. We have worked with everyone from the startup to the Fortune 50 companies, providing innovative solutions. Let's now explore Teksun's mission, vision, and core values. Teksun's mission is to deliver innovative and affordable high-tech solutions to a global community. Teksun's mission is to build a revolutionary technology that benefits everyone. Teksun's core values are world-class products and services, honoring every commitment's positive contribution to the society, and high morals and ethics, innovation-driven culture, crafting a perfect client experience, building win-win relationships. So these are our mission, vision, and core values. At Teksun, we bring together experts across various fields, from the world of tiny embedded systems to the cutting edge of AI and everything in between with comprehensive IT services. Our dedicated teams work together seamlessly to deliver the best solutions. We have successfully delivered 300 projects with help of 300 plus IoT and AI professionals for 100 plus satisfied customers across a wide range of industries, including IoT and Industry 4.0, healthcare, wearable technologies, consumer electronics, security and surveillance, media and entertainment, agriculture, logistics and transport, wellness, fitness, and many more. Notably, we have delivered 100 plus home automation projects across access control system, VMS, biometrics, AI and voice, smart home and offices, and industrial safety as well. Time to explore Teksun business units. Teksun have 3 dedicated business units focusing in fields of embedded systems, artificial intelligence, and IT-enabled services. Embedded system unit deals with IoT, product engineering, multimedia systems, RF, high-speed design, firmware, Linux, RTOS, AOSP, product certification, DFM, electronic manufacturing, and edge computing, and many more. Artificial intelligence unit focus on focus area is artificial intelligence, NLP, machine learning, MLOps, predictive maintenance, computer vision, ADAS, DMS, and recommendation engine, healthcare AI, and many more. IT-enabled services unit provides custom and managed services for the full stack web development, blockchain, mobile applications, which include Android, iOS, and cross platforms, or robotic process automation, and DevOps services. Along with it, we provide enterprise application developments and many more. Freeing your bandwidth while accelerating your time to market, we provide two models. The first model that we provide is product engineering, which provides turnkey product design and development services, backed by the Teksun quality assurance and global infrastructure. There are three scopes: dedicated team, in which we provide a fixed team deployed for your agile long-term product development needs. Second one is time and material. We provide hourly billing for your engineers with material billed as needed. Fixed scope, we provide project quoted with a team based upon defining requirements and timeline. The second model is contract manufacturing. In this, we act as a manufacturing partner for end-to-end production of PCB assemblies, mechanical and packaging, including supply chain management, PCB fabrication and assembly, DFM analysis, product certifications, test automation, product assembly and QA, mold production, packaging, and logistics. Now, let's dive into the monolithic architecture overview and its use cases. Okay, so here the point is monolithic architecture. What exactly is it? Let us explore. A monolithic application is developed as a single unit where all features and functionalities and modules are tightly coupled for the development, integration, and deployment. All the functionalities of the softwares are combined into a single code base, which is usually divided into three layers: the presentation layer, the business layer, and the database layer. Hence, it results in a tightly coupled software architecture. So monolithic architecture is nothing but an application with all the layers, presentation, business layer, and database included into a single unit. Right. So it has many advantages and disadvantages as well. Now, let us look at some scenarios where the monolithic architecture is a good fit. The first one is small applications. It is best for simple, quick to develop apps with one code base, right? Minimum viable product, ideal for quickly building and testing initial version of your app. Limited scaling applications where it is suitable for apps with predictable minimum growth. Ideation phase applications, it is good for early stage projects that need fast changes with the option to switch to microservices later on. Last one is the limited tech expertise. If we have very limited tech expertise, then definitely we should go with the monolithic architecture. Moving ahead, we have microservice architecture overview and use cases. Microservice architecture is a software development approach that involves breaking down an application into smaller, independent services that can be deployed and maintained independently. Each service can choose its own technology stack, manages its own database and CI/CD tooling. Each services are independently deployable, tested in isolation, and communicate via APIs or lightweight protocols. Microservices offer benefits like independent scaling, easy deployment, and fast time to market. DevOps, on the other hand, is a set of practices that combine software development, which is Dev, and IT operations, which is Ops, to accelerate the software delivery process and improve software quality. When these approaches are combined, it results in a powerful toolset that offers numerous benefits for the developers and business. Notable examples include Netflix, Amazon, and Best Buy. Moving forward, we will discuss microservices use cases. Microservices are best fit for the development of the large-scale applications, where managing complex applications with multiple user journeys and modules, specifically when migrating from the monolithic legacy systems. Second one is big data applications. Here, microservices complement the stage of big data pipelines, collecting, ingesting, processing, delivering data by adding specialized services for each task. Real-time data processing applications, where the microservices architecture is used in Netflix and YouTube, which is for the real-time data processing. Here we are using the publish subscribe pattern in microservices as well, suited for these applications. Next one is CPU intensive applications. Microservices help manage CPU intensive tasks such as natural language processing by isolating these processes and preventing these processes and preventing them from affecting the main applications. Last one is the rapid evolving applications. Microservices support the integration of new technologies and strategies, allowing application to evolve quickly without starting from the scratch with each updates. Now, moving ahead, we have monolithic versus the microservice architecture. Here we have two diagrams illustrating the key difference between these two architectures. In first diagram, we have monolithic architecture. Here we can see that there are three different layers: UI, business logic, and data access layer. All these layers are combined into a single unit, and this unit is called the applications. This application can be hosted on a single server. So ultimately, this is a monolithic architecture. The second one is microservice architecture, where along with the UI, different components of the applications can be divided and isolated, deployable on independently on the server. Here, each component will act as a microservice. There might be the case each microservice may have one server or multiple servers. We can deploy multiple microservices on a single server as well. Next, let us compare monolithic and microservice architecture. In monolithic architecture, everything is combined into one single unit. All features and functionalities are tightly connected, so changes in one part can impact the entire system. Where in microservice architecture, the application is divided into small independent services. Each service focuses on a specific task, communicate with the other through API or message brokers, which makes it more flexible and is easy to manage. Next slide, we will see microservices benefits in detail. Here are few main benefits of the microservices architecture. The first benefit that we can achieve using the microservice architecture is faster development and deployment. Microservices allow independent development and deployment of each service, speeding up the delivery times. Second one is scalability. Microservices can be scaled individually. Instead of whole application, here the microservices can be scaled individually, ensuring resource-intensive services are scaled up without affecting others. Improved fault isolation. Isolated services means that if one fails, others aren't impacted, making it easier to identify and fix issues. Next one is improved fault tolerance. Independent services deployment ensures that if one service fails, other continue to function, reducing system-wide downtime. Better team organization. Here, microservices enable teams to focus on a specific system area, leading to the faster development and improved quality. Teams can work independently, enhancing collaboration and efficiency. Continuous delivery. Independent services deployment allows for continuous updates and improvements without disrupting other services, resulting in faster delivery and higher system reliability. And last one is the improved technology stack flexibility. Microservices allow different technology stacks for each service, optimizing performance, developer productivity, and system reliability. So the next segment is microservice tech stacks. Technology stack can be based on individuals, but commonly used tech stacks are as follow. We can use different languages, different frameworks, containers, orchestration software, API management tools, CI/CD tools, and monitoring and logging tools. We can also implement different inter-service communication protocol among the microservices, and we can also implement centralized logging system. PHP, Java, Python, Node.js, Go, and .NET are popular choices as a language. Laravel for PHP, Spring Boot for Java, Flask, Django for Python, Express.js, Angular, React, Redux for the Node.js, ASP.NET Core for the .NET. Here we can use the Docker as a packaging service, which will work as a container for the microservices. Kubernetes is the de facto standard for the container orchestration management. So ultimately here Kubernetes will manage all the containers and hence all the microservices. Tools like Kong, Apigee, and AWS API Gateway will work as API management tools. We can use Jenkins, GitLab CI, Circle CI, Travis CI as a CI/CD tool. Prometheus, Grafana, ELK Stack, Splunk are the monitoring and logging tools. Also, microservices can use RESTful APIs, generic RPC, message brokers like RabbitMQ, Kafka, and AWS SQS as a communication protocol to be done across them. We can use ELK Stack, which is nothing but the Elasticsearch, Logstash, Kibana as a centralized logging system. Along with it, we can use Splunk. Moving forward, we will discuss microservices communication protocols. So here the question is how these services communicate with each other. We know that the whole application is divided into small components called the microservices. Then the main point is here how microservices can interact with each other. So here microservices can interact with each other either in synchronous mode or asynchronous mode. Here in synchronous mode is nothing but the single thread communication model where the continuous connection will be established and once that connection's work is completed, then another work will start. So here we can use RESTful API, generic RPC as a synchronous communication protocols. Asynchronous communication is nothing but the here we are maintaining multiple threads for each services. So here the message brokers like RabbitMQ, Kafka, or AWS SQS can be used as a gateway for the microservices data exchange. Suppose microservice 1 sends data. Microservice 1 wants to send data to microservice 2. So here, microservice 1 will send data to the message broker like RabbitMQ, then RabbitMQ has the responsibility to pass it to the microservice too. So ultimately, all these operations will continue in background in asynchronous mode. Next on our agenda is an exploration of deployment strategies. Okay, so the first deployment strategy is using microservices with the containers, such as Docker, either in single machine with multiple microservices or multiple machines with multiple microservices. With containerization, we can package each microservice and services and its dependencies into lightweight, consistent environment. This approach ensures that your microservices are isolated from each other, making it easier to manage, scale, and deploy them across various environments. Containers are also portable so that we can run them on different cloud providers or on-premises servers with minimum changes. Second deployment method involves use of container orchestration. Container orchestration platforms like Kubernetes offer a powerful solution for deploying and managing microservices at scale. Orchestrators help automate the deployment, scaling, and load balancing of the microservices. They provide advanced features like self-healing, rolling updates, service discovery, making managing many microservices more manageable. Kubernetes in particular has become the de facto standard for the container orchestration. Third deployment method is serverless deployment using the API gateway and cloud functions like AWS Lambda. It is very popular microservice deployment method, and here we are using the AWS Lambda, which is one service of the AWS cloud platform. It provides serverless computing and allow us to deploy the microservices as individual functions that automatically scale with demand. This approach eliminates the need for managing infrastructure and ensure cost efficiency by only charging you for the resources used. While serverless is an attractive option for a specific workload, it is unsuitable for all applications. We need to consider latency, execution limits, and stateless nature of the serverless functions when deciding whether to go serverless or not. Next exciting segment of this webinar is our success story. Case study 1, which is the fintech solution. The client, a fast evolving fintech platform, needed to upgrade its outdated front-end systems to a modern component-based design for better user experience. The challenges our team faced were redesign without disrupting current operations, implement efficient auto-scaling, apply upgrades with the minimum downtime, and integrate with the existing systems. Ensure top security and quality. The solutions our team provided was created independent teams for each services, choose the best technology for each module, conducted parallel QA testing, used leading DevOps practices for faster and higher quality results. Here we have used iOS, AWS, Jenkins, Android, HTML5, .NET, GitLab, PostgreSQL, Node.js, and MongoDB as a technologies used, right? Now discussing our second case study. The second case study is about integrated asset monitoring solution. We have designed a comprehensive solution that includes live location tracking with analytics, geofence capability, on-demand video streaming, motion detection, auto recording scheduling, cloud backup, zero-touch provisioning, OTA updates, and voice control with device management. So here we can see that lots of systems, subsystems are integrated into a single system. That is why it is called the integrated asset monitoring solution. For managing the assets and monitoring it, we have integrated different subsystems. The challenges we have faced: integrating diverse systems, processing millions of data streams daily. As we know that there are lots of streaming related things are going on this integrated asset monitoring system. We have lots of data coming, and we need to process the millions of data streams daily. Second challenge that we face: accessing private camera streams over public networks, addressing GPS data fluctuations, implementing zero-touch provisioning for IP devices, ensuring top security, quality, and minimal downtime. The solutions we have implemented was formed in independent teams, including QA, for different microservices module. Selected optimal technologies for each microservice to enhance efficiency. Applied best DevOps practice for faster and higher quality deliveries. Here we have used AWS, JavaScript, Node.js, Angular, Mongo, PostgreSQL, Python, because we are using here the on-demand video streams, GitLab, HTML5, Jenkins, and Android. Last but certainly not the least, let us explore the last case study, Smart Farm solution. Our Smart Farm solution combines IoT devices with IT services to optimize agricultural practices. It enhances resource use, boosts efficiency, and improves farm management. With advanced technology and data analytics, it supports farmers in making informed decisions, increasing productivity, and driving innovation. The challenges our team faced was advanced analytics, monitoring and control, maintaining high device security, integrating supply chain management, and processing millions of data points daily. Because here in a smart farm solution, we have millions of devices connected together. And those devices were node and master devices. Node devices will communicate with the master devices and send the data. Master device have internet access and it will pass that data to the cloud. Right. So ultimately, we need to process millions of data points daily. The solutions we have provided was implemented microservice architecture, utilized machine learning for the advanced analytics, applied top DevOps practices for faster, high-quality deliveries. We have used technology stacks as follow: React, Redux, Node, Python, HTML5, Android, GitLab, Jenkins, AWS, MongoDB, and MQTT SSL TLS. Thank you, everyone. Have a nice day ahead. Thank you. Bye.
Okay. Thank you so much for this session, Prabhat. Thank you for taking out your time. Okay.